Hi, this is Dr. John Bergduff. This is going to be a probability example that involves a sequence of choices and therefore can be solved easily using a tree diagram. So let's read this one together. Below are three boxes containing black and white balls. The number of each color is noted inside the box. Draw a ball from box 1 and place it in box 2. Then draw a ball from box 2 and place it in box 3. Finally, draw a ball from box 3. So the first box has 4 white and 3 black balls. And the first thing that we do is we draw a ball from that box. Let's draw a branching tree that represents the outcomes that could happen when you draw a ball from that particular box. Well, it could be one of two things. It will either be white or it will be black. Now, looking at the box contains a total of 7 balls. If 4 of them are white, then the probability of drawing a white ball would be 4 over 7, and we'll put that fraction right there. The probability of drawing a black ball would be 3 over 7. Then we draw from the second box, sorry. Now, if all we were doing was just looking at the second box as it is, we would basically be doing the same thing we did on the first draw, looking at a total of 4 balls in box 2. 2 of them are white or 2 of them are black. But whatever you draw out of box 1 gets put over into box 2. So what will happen will depend on what you chose for the first ball. If you ended up choosing a white ball from the first box and you put it over here in the second box, now there are 3 white balls out of 5 total. So we remember that we've added a white ball to this box. So 3 of them are white out of 5. The probability of drawing a white the second time would be 3/5, whereas the probability of drawing a black would be 2/5. So we write those probabilities on the tree, 2 out of 5. Then we forget about that and go back and say, well, what if the first ball that I picked was black? So now I've taken a black ball from box 1 and put it into box 2. There's 5 balls in box 2, but this time 2 of them are white and 3 of them are black. So when we draw from box 2 as it's been altered, we could either get a white or a black. The probability that we would get a white would be 2 out of 5, because again, the ball we added was a black one, so it's 2 out of 5 for the probability of white, but 3 out of 5 for the probability of black. This fraction is a little sloppy. Let me rewrite that. 2 over 5. 2 over 5. Then as we look to see what happens in box 3, remember that whatever you draw from box 2 goes over to box 3. If your draw from box 2 is a white ball, then box 3 now has 2 white balls and still no black balls. So as you pull from box 3, to be complete, we might say that the options are white and black. And you might say, wait a minute, not so sure about the black, but that's okay. We'll deal with that in a minute. There are, remember, 2 balls in this box at this point. They're both white, so the probability of drawing a white would be 2 out of 2, which reduces to 1. And the probability of drawing a black, well, there are no black balls, so the probability would be 0. I could have done this tree the same way by realizing that there were no blacks to pick from and just leaving this branch of the tree off. Doesn't really hurt. You're just going to get an option where the probability is 0. Now, on the other hand, if what you pull out of box 2 is black, box 3 now has 1 black ball and 1 white ball. So the probability of drawing white is a half, and the probability of drawing black is also a half. Now, let's go back and say, well, what if we are down here in this branch? If we had picked a white ball from box 2, that goes over into box 3, and you realize, oh, this is going to sound a little familiar. With the white box in box 3, there are 2 white balls and no black balls. So the probabilities become 2 out of 2 for the white, because there's 2 balls, they're both white. 0 for black. That sounds familiar. On the other hand, if what you picked out of box 2 was black, you put that over here in box 3. Now there's 1 white and 1 black. So these probabilities are again 1/2 and 1/2. That's my cat Samson, who's going to help us with this problem. Okay, I may need to move his little nose in a minute. Now, as we look at this whole sequence of choices, the outcomes that we have represent the sequence of draws that we have. Going down this branch from Samson's nose of the tree, this branch would mean we picked a white ball first time, a white ball the second time, and a white ball the third time. The probability of a sequence of events is found by multiplying the probabilities of the individual events that get you there. So if I make a list in this column of all the outcomes that are possible, one of those outcomes is to draw a white, followed by a white, followed by a white. And the probability of that would be the product of these probabilities. 4/7, 3/5 times 1. 4/7 times 3/5 times 1. Multiply the three fractions together, it gives you 12 over 35. Hope that makes sense. This branch of the tree gives me another outcome, white followed by black. That probability is 4/7 times 3/5 times 0, because there are no black balls in that last draw, and therefore that probability is 0. Go down another branch, white, black, white, white, black, white. The probability would be 4/7 times 2/5 times 1/2. That's kind of a nice one because this 2 would divide that 2, and my probability would be 4 over 35. That's pretty nice. White, black, white. Next one would be white, black, black. White, black, black. And that'd be 4/7 times 2/5 times 1/2. Oh, that's that one. White, black, black. Same probability as white, black, white. The 2's divide out, giving you another probability of 4 over 35. We'll continue down the next branch of the tree, down to where the first ball drawn was black. And we have options like black, white, white. That's an outcome. We'll put that right here. Black, white, white. Black, white, white would give me a probability of 3/7 for the black, followed by 2/5 for the white, followed by 1 for the final white, 6 over 35. Black, white, black would give me 3/7 times 2/5 times 0, because there won't be any black balls in that last option. So that probability is 0. That's okay. Black, black, white would be from here to here to here. The probability is 3/7 times 3/5 times 1/2. And that would give me a probability of 9 over 7 times 5 times 2 is 70. So a different denominator than we've seen. And the final last option would be black, black, black. These are all the possible outcomes that you could have in this game that they're talking about. This one would be 3/7 times 3/5 times 1/2, gives me the same probability of 9 over 70. Now, suppose that the question has a couple of follow-ups. These are all the outcomes and the probability of each one. The follow-up questions might be, what is the probability? And I'll need to slide my camera down a little bit. What is the probability that the final ball drawn is white? This is an event that consists of a number of outcomes. Some of these outcomes end in a final ball of white. When you have different outcomes and you're looking at the probability of an event that consists of the collection of those outcomes, what you do in that case is you add up the probabilities of each individual outcome. So which outcomes end in white? Well, white, white, white would be one. White, black, white would be another one. Tell you what, let's write the probabilities while we go. That's a probability of 12 over 35. White, black, white gives me a probability of 4 over 35. Okay, my cat's getting in the light a little bit. Excuse me, buddy. Can you slide a little bit? There we go. Good boy. Okay, he doesn't really want to go that much. We also have another outcome that ends in a white. Black, white, white. That probability is 6 over 35. And then finally, black, black, white. All these end in a white. That probability is 9 over 70. So the probability of having your third ball being white would be the sum of the probabilities of these particular outcomes whose union, so to speak, represents the event of drawing the white ball last. To add these fractions, I'll need a common denominator. I'll have to write them all over 70. So some of these I'll have to multiply numerator and denominator by 2. This becomes 24 over 70, 8 over 70, 12 over 70, and then we have the 9 over 70. Add those up. Let's see what we get. 24 plus 8 is 32, plus 12 is 44, plus 9 is 53 over 70. The probability that the second ball drawn would be white is 53 over 70. What is the probability? This is another follow-up question. What is the probability the final ball will be black? Final ball drawn is black. There's several different outcomes that consist of or that create that event. This one, white, white, black. This one, white, black, black. This one, black, white, black. And this one, black, black, black. I can add up those individual probabilities, some of which are going to be 0. I'm sure we can still see that. Yep, 0 plus white, black, black, 4 over 35. Black, white, black, that's a probability of 0. And black, black, black is 9 over 70. Let's stay on this line so we don't go off the bottom of the screen. Pretty simple, 4 over 35 plus 9 over 70. That becomes 8 over 70 plus 9 over 70, which adds up to 17 over 70. And that's the probability that the final ball drawn is black. Interestingly enough, these two events together would create or represent the entire sample space, because the final ball drawn is either going to be white or it's going to be black. So as a nice check, it should be the case that these two probabilities would add up to 1, and they do. Add those together, you get 70 over 70. So I hope that that is a nice example with a cameo appearance from my cat of doing a fairly complex probability problem with stages that can be solved using a probability tree.